Hi, eighth graders. We're going to be talking about motion today and being able to describe motion, in particular, looking at position and distance and displacement, and then talking a little bit about how we describe motion in terms of velocity and acceleration. So let's move on to motion. Okay. First of all, when we talk about motion, motion is any process that changes the position of an object. Okay, and when we are looking at that object, we're always going to start with a reference point. So let's say when we're talking about something, we're looking at the location of your house. Well, we need a reference point when we're looking at your house. So we might say, where's your house from Drake Middle School? So that would be our reference point. Okay, and then the distance is the total length of your path of motion. So if I'm going from Drake Middle School to your house, how far away is it? What's the distance? Okay, and then when we talk about distance, an alternative term that is used is called displacement. And displacement, if we look at this graph, this kind of describes it, right? This individual is walking home. Okay, the displacement would be the distance from this tree to their house. But the distance they actually have to travel to get home is 4 meters and then 3 meters. So the distance and the displacement are not always the same thing. Okay, whenever you're describing motion, you need to include the reference point, your displacement, and the direction that the individual is traveling. Okay, so those are some basics about motion. Okay, once we have an object that is in motion, okay, lots of times we describe that object based on its speed. And speed, I think we're relatively familiar with, is the distance an object moves divided by the time it took to move that distance. Okay, and down here, this is a really handy, it's called a formula triangle. Okay, and the formula triangle, it has a D on the top of the triangle, an S on the left, and a T on the right. So the D stands for distance, S stands for speed, T stands for time. So you might want to copy this down. The distance is going to equal speed times time. So you see how in blue, that's the distance, that's the number on top. The number on top is the two numbers multiplied on the bottom, the two numbers on the bottom multiplied together. Okay, then the speed would be the distance over the time, or distance divided by time. Okay, and then I don't know if you can see down here at the bottom, okay, but the last term would be time. Okay, and time, okay, is in this bottom corner. Since it's in the bottom corner, it's distance divided by, or distance over, speed. Okay, so that just allows us to rearrange this equation to find either the distance, the speed, or the time. Okay, and we'll talk a little bit more about the math of that later. Okay, speed can be constant or it can be changing. Okay, so constant, right? That means that the individual is traveling the exact same speed per unit of time. Okay, which generally doesn't happen, but maybe if you're driving through Kansas or Nebraska, hey, your parents will put your car on cruise control, hey, and that allows the car to travel at the exact same speed as you're going across that nice flat surface, hey, of the highway. So that might be a time when speed would be constant. Okay, speed is changing when the distance traveled per unit time does not remain the same. Okay, and then average speed is just the ratio of the distance moved and the time it took to move that distance. Okay, so you might think about that in terms of, like, if you're a runner, okay, and you go out for a run. Okay, when you go out on that run, you're not always going the exact same speed, right? So maybe you start strong and then you kind of slow down as you're going along. Or maybe you're the other way around, where you run kind of relatively constant speed and then you pick it up that last mile or last maybe just a few hundred feet or something. So when we talk about average speed, the average speed isn't the speed right there at the end or sometime in the middle of your run. The average speed is what's the overall time it took you to complete that distance. Okay, so that's called your average speed. Okay, velocity is slightly different. Okay, so when we talk about velocity, right, it has to do with the speed and the direction. So we can see Spider-Man here, right? So he's falling. Okay, the velocity is down, okay, towards the surface of the earth. Okay, so velocity, since it's the speed and the direction, we use an arrow to represent it. Okay, and the length of the arrow indicates how fast the object is going. Okay, and then the direction that the arrow points shows the direction that the object is moving. So this would be an example. Okay, if we're talking about a car, the car starts off maybe relatively slowly and gets faster. So this is a longer arrow that indicates, okay, that the speed has increased. Okay, and since it's pointing to the right, okay, so the velocity has to do with the speed in this particular direction. Okay, when we talk about velocity, okay, an object's speed and direction both have to stay exactly the same in order for an object to have constant velocity. Okay, so when we're looking at, hey, this jet and this car, they were racing, right? And so when they're racing, okay, sorry, I'll mute that. As they're racing along, hey, they are going to try, hey, to actually stay at the same speed as each other. So you see them kind of racing right along next to each other, and then this car actually increases its speed, but the jet catches up really quickly, right? And so they don't have constant speed, right? They are not traveling at the exact same speed as each other. Okay, and that's because they're either speeding up or slowing down. Okay, constant speed, they would have the same exact velocity. Okay, and the direction they're traveling would stay the same. Velocity changes when the speed or the direction changes. Okay, so we see down here, okay, a little Harlem Globetrotter action. Okay, so when they bounce the ball like that, right, the ball is going up and then it comes down. Okay, so the direction the ball is moving, hey, is changing. So whether or not the speed is staying the same, okay, since the direction is changing, that means that the velocity has changed. Okay, so it can either be speed changes, direction changes, or both. Sorry. And then a measure of how quickly an object's velocity changes is called acceleration. So that's a word that we're pretty familiar with. Usually we always think of acceleration as getting, maybe like common way of describing it would be going faster. Okay, so when we're looking at acceleration, okay, it can be calculated by dividing the change in velocity by the time it took for the velocity to change. Okay, so that's a little complicated. Change in velocity, that's kind of fancy for the difference in velocity, or you take your final minus your initial velocity. Okay, and then by the time it took for the velocity to change. Okay, so again, we have this little formula triangle, okay, and it tells us acceleration, A, equals, okay, and again, okay, we have change in velocity over time. And we could rearrange this, okay, and find time instead. If we know what the velocity and the acceleration are, we would do the change in velocity divided by acceleration, okay, and we could find the change in velocity by doing acceleration multiplied by time. So when an object speeds up, its acceleration is positive. When an object slows down, its acceleration is negative, and we usually call that deceleration when it slows down. We are going to be talking a lot about using graphs to represent motion and actually being able to understand what those graphs represent. So when we're looking at motion, the first kind of graph that becomes important for us is displacement over time graphs. Okay, so we're representing that with the D on the side here and the T here. So the D is on the y-axis, the T is on the x-axis. Okay, and when we're looking at that, a displacement versus time graph tells us something about velocity. Okay, if it's a diagonal line up, there's constant velocity. If it's a flat line, zero velocity. and it doesn't matter where that flat line is. Okay, if it's curving up, there's acceleration, and if it's curving down, it's deceleration. Okay, the line does not show the actual path of motion. Okay, so we don't know kind of what path the object that's moving is taking. Okay, this just tells us about the average speed of the object. There are also speed versus time graphs, and speed versus time graphs tell us about acceleration. Okay, so a point on this line represents the speed of the object at that time. Okay, and if we have a horizontal line, that means, okay, so this is velocity or speed, okay, over time. Okay, if the line is flat, if it's horizontal, or y equals if it's flat, that means that there's constant velocity. Okay, if the line slants down, okay, then there's constant deceleration. If it slants up, it's constant acceleration. So those are the key things related to different graphs and looking at motion. So I hope that helps you guys kind of get a good base understanding when we're talking about position, direction, displacement, speed, velocity, and a little bit about acceleration in some of our graphs. All right, ladies and gentlemen, I hope you guys have a great day. See you soon.